Hi, good morning, folks. So today we're going to talk a little bit more about object-oriented programming. Specifically, some of the things that we didn't quite get to last time, things like visibility and a little bit on sort of package stuff, and we'll talk a little bit about scanner as well. So then near the end, it'll sort of have like a hodgepodge of little sort of OOP things using objects as arguments and sort of other things like that. So we are going to take the code that we worked on last time, that sort of rectangle and circle code, and we are going to be adding to that today. All right, so we've seen these sort of visibility modifiers throughout the semester. So mostly sort of associated with data variables. So we'll say something like public, or what we'll see today, private, and then what you'll get more next semester, protected, or with methods. So when we write our methods, we've always said like public static void main, or when we've written our own methods for our own programs, just public static, or just public in these classes. So this keyword and the others that are associated with it correspond directly to who can access those variables or those methods. So public, as you might imagine, means that anybody can access it. Private is more restricted. Protected is also more restricted. And then there's sort of a default one. If you don't use any of these other keywords, if you don't put public or private or protected, then it's this sort of package private concept, which I'll mention packages a little bit today, but they're not sort of super important for CS1. So most of the time when you create variables in your classes, for instance, you'll want to use something like public. So as an example, let's say we have two classes. And for now, we'll just be a little sort of hand wavy and say they're both part of the same package. So if I have two classes and I have a method or a variable in class B, if that variable or method is public, then class A can access it. And we've sort of seen this already. So let me go over to the circle and the rectangle code. So we've got a public method called getArea, and a public constructor called rectangle, and a second constructor called rectangle is public, and two public variables, height and width. So when we go to the example code in a different class, this is a class that is different than our rectangle class, two separate classes, I can access my public methods and public variables. So that's what I mean by accessing public methods or public variables. If I create a circle, it's part of, or it came from a different class, then I can still access its public things. It's what it's showing to the rest of my program. It's showing that it has a radius variable, and it has the rectangle has a height and a width variable, and they have their getArea methods. So that's what I mean by public, by sort of anybody being able to access it. If a method or variable is private, then another class cannot access it. So we're going to mess around with this sort of public-private thing today. We're going to change a couple of our variables to be private so you can see what sort of error you get from that. So private, other classes cannot access it. Protected, it's something you learn more about in CS2 if you're going on in computer science. It depends on the relationship between class A and class B. Depending on the relationship, it may or may not be available. So I just have a little check mark here. The default, if I don't put anything in front of my variable or my method, so if I just have double height or double width or double radius or whatever without a public, private, or protected, then if the classes are part of the same package, then it's accessible. If they're not, then it's not accessible. So it's one of these sorts of extra layer that this sort of package thing gives us in Java. We're not going to use packages really at all. We're not going to create our own packages. They're really used to help you organize classes. So I'll talk a little bit about them on the next slide, but you're probably not going to use them too often until you get sort of further along in CS, if that's where you're headed. If you don't explicitly put a class into a package, so when you create a new class, if you don't put it into a package, it will automatically belong to this sort of standard default package, which for this class, for CS2, that's typically sort of all we need for the work that we're going to be doing. So for the most part, you don't have to worry about packages. However, if you do have separate packages, then the only way to access other variables is public. So public is very free and open in terms of classes accessing other classes' variables, whereas all the rest are restricted, are restrictive in one way or another. If you have to cross sort of different packages, then public is the only way to access variables. So think of them as, do you need this variable to be accessed from other classes? If you do, then making it public is the way to go. If you don't, making it private is, and then you can decide on the other two, protected or default, depending on the situation. So most of the time for this class and for most of CS2, we're just going to be dealing with public and private, with a little bit of protected when we talk about that sort of stuff in a CS2 class. Java does let you package things very easily. If you look at your homework, you'll notice that there is a package related to your homework. Essentially, at the top of your file, you just say package and then give the package a name. And you can package up as many classes as you want. So say you made a whole bunch of classes that are related. Say there are a bunch of shapes. We made 2 shapes so far. We have rectangle and circle. Maybe you make a whole bunch of shape classes, and you decide, well, these should be all part of the same package because they're sort of similar classes. They all have sort of similar uses. Okay, you could make a shapes package. So something like this, for example. So we have a circle class, and it's in this package called shapes.examples, for instance. Whenever you import something, so when you need to import Java util scanner, you are importing from a package, java.util. There's lots of built-in Java packages. So that's why you don't have access to everything in Java to start with, because they're all in separate packages that do specific things. So when you need to import scanner, that comes from the package Java util and is the scanner class. And so that's why you write import Java util scanner. So that's sort of the basics of sort of what a package is. Again, you don't really have to use them yourself. You don't have to create your own, but you do import classes from other packages when you need them. And we will do more of that as we sort of continue on in the semester. All right, so far for basically everything we've written, either class-wise or method-wise, we've used public. So back in our code, we have a public double called height and a public double called width. So that's some of our data in our class. There, it's public. It's available to everyone. Same thing with our constructors. Same thing with our methods in both rectangle and circle. They're public. We didn't put public here in front of circle, but that's something that we could do as well. That means that the class data and all those methods can be accessed from anywhere in our program. Essentially, we've exposed that data and exposed those methods to everyone. So that leads to potentially a question and a look back at those 4 pillars of OOP. If we use the public modifier everywhere, does that conform to abstraction, that abstraction principle that we talked about last time? Remember, abstraction is only showing what you need to show and keeping the rest hidden. Remember, I talked about sort of a computer, right? The thing that's sort of shown to me as sort of an outside observer at the computer is like the power button. I don't need to know all the rest of the things that are happening. All those things are hidden. If you think of the data in your computer as voltages and currents and all of the pieces that are all connected together and how they interoperate to turn the computer on, just as a simple example. I only have a button. Think of that button as public. Think of it as a method. Turn on. Public void, turn on computer. I can access that button, but I can't access the voltages, at least not directly from like the chassis, from like a physical perspective. So when you think about your class, when you think about writing a class, if I make everything public, then that would be like exposing all of the parts of my computer and letting me tweak them and mess around with them and be able to see what the voltages are and what the currents are from sort of an outside perspective, rather than just the power button. So in this case, using public everywhere does not conform to that abstraction principle. There are things that we want to hide, internal things that we don't want every class to be able to directly manipulate. Typically, what you're going to do when you write a class, and this should be the sort of the default behavior when you first write a class, you're going to make all the data fields private. Remember, private restricts access to the data or the specific methods so that no outside classes can access it. So you'll typically make the data fields in your class private. That's one of the ways that we can conform to the abstraction principle. The encapsulation principle, which is closely related, is us taking all those similar values, those similar data and methods that work on that data, and putting it in a class in the first place. And then abstraction is taking the things that we don't want everyone to access and making those private. That's why those two are so closely related, abstraction and encapsulation. So we are going to privatize that circle. So this is the circle that we currently have coded up. And the only change here is changing our radius to private. That's it. That's all I'm going to do. So it's only going to be able to be accessed within this class. So the code that I currently have here, it's perfectly fine. I can still access the radius variable within the class where it's created. So then there's another question. I have two other publics here. Should I make these private as well? Let's think about what they do. Get area, set radius. These are things kind of like our power button. If I have a circle, I might want to know the radius. I don't need to direct, or I might want to know the area. I don't directly need to access the radius because I have a method that uses the radius to compute the area. If I want to change the radius of the circle, that's what my set radius method here is doing. So we allow access to certain pieces of data through our methods. So most of the time, the majority of your methods are going to be public. So that if you want to access or change or use the data in some way that's private, you do it through a method. So that sort of further corresponds to the sort of abstraction thing. We can say get area. It doesn't matter how I compute the area. I'm using radius times radius, but you might use math.pow, radius star 2 or radius and 2. Doesn't matter how I do it. I know that this will compute the area. And so that's my public sort of outward facing method so that I can easily access information about my circle. This changes our UML diagram slightly as well. Anything that's private, you'll either see some sort of other symbol if you have like a graphical diagram, or if it's just a text diagram like this one, you'll see minuses for things that are private and pluses for things that are public. So we'll add sort of a couple more things like this onto our diagrams, sort of as you go on, and potentially in CS2 as well, we'll sort of add more features to our diagrams as we go. So all the sort of little pieces of these diagrams, they can come together to help you write or understand what a particular class is doing. So we're going to see, we're going to go in and mess with the circle class and sort of see how that looks here in a second. But does anyone have questions about public or private and why we use them? All right, so let's go and do this. Let's take this, let's make it private. It didn't mess up my class or anything at all. Everything still works perfectly fine. But in my example code here, the one where we actually create a circle and print information out, I now have an error when I try to do this. When I try to say c1.radius, right, how here it says the field circle.radius, so my radius variable, is not visible. So this class knows, and Eclipse sort of overall knows as well, that, hey, you're trying to use radius, but it's private. Get area is still fine because it's public. We're all good there. But if we want to print the radius, there's actually no way for me to do that. I can set the radius, but I can't access the radius here to get the value. So oftentimes what you will see with your classes, and you should sort of think about this for the variables that you might want to access from the outside. Again, by default, make all your variables up here private, and then think of other ways to access them. So I need to change this code. I can't do this. And if I'm following abstraction, I can't just go and make it public and say, I'm good to go. I need to think of another way. This is where you'll see this concept of setters and getters. We have a setter written right here. Set radius. This allows us to change the radius without directly accessing the private variable. So I could do the same thing and create a getter. Public. Now this is going to be called a getter because it's going to be get radius is the name, and it's going to return a double because it's going to give me back the radius. So this will be get radius, and I'll return the radius. Setters and getters are very common. Most of the time when I code them, I usually put them at the bottom of my class as sort of the last piece of my class. Usually you don't have to change them after you write them. So I'll usually put them down at the bottom. So I'll say something like setters and getters. So that's for my radius. So I can set the radius, I can change it to something new, and I can get the radius if I need it without ever making the radius variable itself public. Now, there are some questions that I usually get from this. You're writing more code here. If you just make this public, you can just directly access it and you're good to go. So why write a bunch more code if making it public will just work? Besides the whole sort of breaking the sort of abstraction principle. Let's say you had a program that was drawing a circle to the screen. That's sort of a concrete example. You have some sort of graphics program. So we deal with sort of graphics in CS2, but sort of say you have a bunch of that stuff written and you're drawing a circle to the screen. Maybe it's a projectile from an enemy weapon or something. You need to draw the circle. If you need to change the size of the circle, that could be sort of easy to do if the variable was public. You could just say radius equals whatever, a new radius, 10. And then if you need to change the size, maybe the weapon or the projectile gets smaller as it moves. So it starts out big and then gets smaller. So every single frame of your game, you got to make that radius smaller. So you start out at 10, and then you go to 9, and then 8, and then 7, and so on. If you change just the radius like this, you would have to code up a whole system to check the circle's radius and then redraw the image. Whereas doing it this way with set radius, I could do something like this. I could say radius equals new radius. So I set the radius through a method, but now I can do other stuff. I can redraw right here. And then maybe I can play a sound. or play an animation. I can do more things than just change the radius. Whereas if I access this directly and just say radius equals 5, I can't do all of this other stuff at the same time. You'd have to make sure that you coded it up with a whole bunch of extra stuff to do them all at the same time. Whereas this way, I call set radius and I can do tons of things. That's the power of doing things through a method. You have the control of what happens. So you see this very commonly in sort of most programs that you'll play around with. No direct access to the variables because you access it through a method, which then you can use to do other stuff. So I could potentially tell, when I set the radius, I could do other things like do some other physics stuff as well. I can potentially bounce off of a wall and do whatever. If the radius grows or shrinks down, maybe I need to check and see if it's hit anything. And so potentially I can do that, do some of that actions during a change of the radius. So that's hopefully a little bit more sort of concrete example as to why we don't always want to access our variables directly. Why you want to do it through a method. So setters and getters, very, very common. So do that. So if we go back to our example here, we have the get radius method now. So if we go back through our example, we can change this guy to get radius. And we can change this one to get radius. So now we're doing it through a method rather than a direct access. We've followed this abstraction principle, and we have our setters and getters that we need to continue to follow this abstraction principle. So let's update rectangle to do the same thing. So I'm going to make the height and the width private. And then down here at the bottom, I'll make a pair, a setter and a getter for each one. So these will be public, of course, because we want to be able to actually use them. So I'll have a set height. This will be a double new height. Say height equals new height. And we'll make a setter for the width as well. So I'm just going to copy this one and change everything here to width. And then we'll write a getter as well. We'll have a public double get height. And return height. And same thing for the width. So it is more writing of code. But these will give you a lot more flexibility if you need it. So now if we want to access our height or our width, we don't have to go directly through here. I think in the example code, I didn't do that. We were just using get area to begin with. But this is now our sort of privatized rectangle that we are better following one of those core pillars of object-oriented programming, making our data private and then providing access to what we want to have access to. We don't have to write these functions for every variable. If you have a variable that never needs to be changed, then you don't have to write the setter. If you have a variable that no one ever else needs to interact with, no other code is going to need to access in any way, then you don't have to write a getter. Some languages, depending on what languages you may know already or languages that you'll learn in the future, some of them have different ways to do this, more compact ways to do this type of sort of setter getter thing. But sort of the standard way that will work for any object-oriented language is something like this, writing some separate setters and getters. Yeah, so our the rest of this is just sort of showing that our program didn't work, so we needed to write a getter, and then we could throw it in there, and then we have our new rectangle now with some. Here I just wrote the getters, but we wrote the setters in the code as well. So making our height and width private, and then adding some methods to be able to get or to set that height and width. All right, so the next thing we're going to talk about is a little bit related to scanner. So is there any questions on this so far? All right, so when we use a scanner, remember that we create a scanner with scanner input equals new scanner system.in. So we've been seeing how all of these parts actually work now. So if I do pull up the annotation, go. So it's the same way that we create sort of any variable. We have our type. We have the name. And we have that initialization. But remember, the piece that is here, the scanner and then system.in, that's the constructor. So scanner is just a regular class. It's a class that someone else wrote, but it is just a class, just like we've been seeing with this circle and this rectangle. So it has a bunch of methods that are public, like nextInt and nextDouble. And it has other methods that we'll talk about in the future called like hasNextInt and hasNextDouble. So it has a whole bunch of methods to use that are public. And if you want to see what those are, in Eclipse, you can do an autocomplete. So let me come in here and create a scanner. Scanner, I'm just going to call it inputs equals new scanner system.in. So this is the sort of equivalent to me making a new circle for my own with my own circle class. In this case, scanner is not part of our current project. So that's why I need to import it from a separate package that's being imported from Java util. And then if I say input dot, these are all of the methods that are associated with scanner. So if you went into the scanner code, you're going to find most of these methods, not all for various reasons that you'll learn about in CS2, but most of these methods you will see in that file itself, that scanner file. So next double, next float, next int, next line, next long, next short. You'll see things like toString and use delimiter, and you'll see all of these things. You'll probably see other methods as well. You'll probably see methods that are private. So private methods are not going to show up in this list. Think of them as being used internally. As a user of a scanner, I don't have to access them. But other methods might access them. So that would be sort of where you would use a private method. If the outside doesn't need it, but the inside might. So all of those methods, this is what is in there. And that's why if I create, so I'll get rid of this here. If I have my circle here, C1, and I do a dot, there's a whole bunch of methods in here too, for various reasons that we'll talk about in the future. But you should find the methods that we wrote. Get area right here. And then down a little bit further, set radius. Those are the methods that we wrote. Like I said, there are other methods in here. We're actually going to look at the toString method today. But the methods that you write that are public will be in here as well. So that's what the autocomplete's looking for. If you've been using the autocomplete to sort of help you write the scanner.nextInt and nextDouble and potentially some of the other stuff like math dot and then pow or squirt or abs or whatever, that's what you're doing. You're looking through the public methods that are available in that class. Of course, accessing the methods, easy. After the dot goes the method name, and that's where the autocomplete can help you out. So methods like next and next line and has next line, like I said, they're all part of the scanner class. So your generic form for calling a method from any object, so from any instantiated object from some class, whether it's a class you wrote or a class that's built into Java, is just whatever the object name is, so input or C1 or whatever it's called, dot whatever the method name is, and then whatever arguments you need. And if it has a return value, then you capture that return value. That's why we've always written input, the object name, dot next line, doesn't take any arguments, and we save that into, in this case, it would be a string variable called line. The key here is that this must be an instance of an object. So that's why I have to create a scanner to begin with. I have to create a new scanner in order to call methods related to that scanner, because it has to be an instantiated instance of that class. If you don't have an instance of that class, then you will get an error if you try to call one of these methods. So if you didn't create a new scanner, then it wouldn't work. The convention for Java is to have one class per file. That's not always necessary, so there are ways to get around that. But your standard convention, and the one that you should go with, and the one that we'll do in this class, is to have one class per file. It's common to have a single class that has nothing but main. That is what we've been doing. We've got this class here, this class called example, and all it has is main. So this is a very common approach when you're doing sort of a lot of OOP stuff. You'll have a class that just has main and nothing else. I've written programs before that might just have this. So for example, for a game, I might just have something like run game. And that would be it. Or I might have something like game G equals new game, and then say g.run game. And that would be it. That would be all that main does. So oftentimes main is very small. Depends on how you sort of go about programming stuff. But main can be a very sort of small program, a very small sort of amount of code. When we get to graphic stuff in CS2, there's one line in main. And that's it. And that's sort of the standard way to use JavaFX. So oftentimes main is very small, and you'll have just one class with a single method, main, and then maybe a couple lines in it, and that'll be it. So don't expect to always put everything in main. There will be sort of, in the future, you will most likely do something more similar to this than shove everything in main. It provides you sort of a simple entry point to the program. So if someone wants to see what's the first thing that happens in the program, they go to that single class, that sort of main class that contains the main method, and they see that, oh, it creates a game object and then run game. So then they can go to the game object and take a look at what that does. You will likely have many classes in a single project. So in this one, I've got 3. I've got circle, example, and rectangle. Let me actually go back to have the speed sort of normal here. You might have dozens of classes or hundreds of classes. For something that's very complicated, that's perfectly reasonable. So don't expect to always just have 1 or 2 classes or something in your programs. It will start to get complicated, and you will have lots of Java files. The organization of them is something that you might have to think about in the future as well. Do you want to put separate ones in different folders and stuff? For now, everything can just go sort of in this case, in the default package sort of folder here. But if you have more complicated stuff, maybe you're writing a game for a CS2 final project and you have a bunch of enemy types and they all have different classes associated with them, then you could make an enemies folder and throw them all in the enemies folder to try to keep organized. So that's where some of this package stuff comes in. When you start to have lots of classes that are related that you want to sort of separate out so that you don't have to have them all sort of in the same default package. And when it comes to memory, we talked a little bit about memory at the beginning of the semester. When you create an object, memory is set aside for every piece of data in that object. So whenever we create a rectangle, so if I say rectangle, in this case rectangle A equals new rectangle, in memory at some random address, I get space for 2 doubles because I have a length and a width, or height and a width in our code. We'll get a default value in here. Depends on the type. So for a double, it should be 0. If I create another rectangle, then I get brand new space for that as well. Rectangle B now has a height and a width, or a length and a width, and it gets some space set aside. And then if I start setting the values, so I set the length and the width on both these rectangles, then their values get put into those memory locations. That's what the new is doing. When you say a new and then you call a constructor, it allocates memory. So it sets aside space in your RAM so that this object can exist and that you can access it and then do whatever it needs to do. It doesn't only do this with the variables. It technically does it with the methods as well, but that's not something that we usually have to worry about. So for now, just think of it as the variables. When you create a new object, so like my new circle, as soon as I run this line, there's space in the memory for the radius, that radius variable. So if I were to create, say, 1,000,000 rectangles or 1,000,000,000 rectangles in my code, now I'm going to start using up a more significant portion of my memory. Because even though it's only 2 variables, 1,000,000,000 of them is actually a lot. It's going to be a lot of space on your computer. So it is worth sort of keeping this in the back of your mind, that whenever you create a new object, it does take up memory in your RAM. I want to talk about a little bit more about printing as well. And this is where some of that sort of like hodgepodgey type stuff comes in. I want to talk about printing because you can print just an object name. So I go back over to my code here. Let's just print out as the circle 1 here. Let's just print out let's print as a string. Let's print C1. So I'm just printing literally the circle's name, what I've named the circle C1. There was no error. It just did it. This actually gives me some information. It tells me that C1 is a circle. That could be useful. Maybe I didn't know what it was, and in my code I was like, all right, let's print it out and see what it is. Okay, it gives me some information. And then it has an @ and then it has a number. It's actually a hex number, so you will see some letters in there. That number is related to where it's located in your RAM. So this will likely be different for everybody running on their computer at the moment. So what this is actually saying is that C1 is a circle object at this RAM location. So it tells me it's a circle in memory. It's probably not all that useful to print out to the user running the program. If you were playing a video game or something, and then all of a sudden it told you that your character's data was stored at some hex value, you're probably not going to care as you're playing the game. So just like if you were to print this out to the user running your program, they're probably not going to care either. But we can change the behavior of what this prints. we can change what printing my object, printing my circle means. This is very, very powerful. This is something that you will most likely use a lot. When we do our blackjack game that I typically do as a project in CS2, we will use extensively the two-string method because it will help us to build up what we're going to print and show to the player. For example, you'd want to print out all the cards in your hand, what they are, and then you probably want to print the total value of the hand, for example. And so we can do that by using two-string in very cool ways. So that's where this two-string thing comes in. So the reason why you can't print an object directly, at least have it useful print out directly, is that how would the JVM know what to print or how to format it? How would the JVM know that you want to print out the radius? So it does a default of the type at the memory location. You could write a print method. So let's do that right now. So in my circle, I've got my set radius, I got my get radius. Let me delete the comments here. Got my get area. Let's write a quick print method. So we want it to be public because I want to be able to access it outside of this class, and it doesn't need to return anything. Actually, yeah, let's do it. Let's do it in a couple of ways. So it doesn't need to return anything, and I can just call it print, and it can literally just do a print. So it can say radius and a %f and a %n, and it'll print out the radius. So it's literally just a print. Okay. So back in the example code here, I'm going to keep this one in, printing it as a string, but then I'm just going to call c1.print. So there we go, radius 10. That's a reasonable thing to do. Let's change it slightly. Let's say I don't just want to print directly. Let's say I want to have this return a string. So I'm going to get rid of the print from here, and we're going to return, say we return a string that says radius. Now I'm not going to put the value in just yet. We'll get to that in a second. So if I call print, it's going to return a string. And I can set that string to whatever I want here in a moment. So now this print doesn't really make any sense. But if I return a string, then I can say c1.print in my printf out here. Do this, and we print out the radius. So I could return a string from a method and then print it like this if I want to. Now, I do this for a point. We're building up to the two-string. So the print method can work, but the better one to have is what's known as two-string. It's a method that returns a string, just like the print that we wrote, but Java actually figures it out for you. Java finds the two-string automatically. So let's change the name of print in my circle class. So I'm going to name this two-string. It has to be exactly like this. And you'll likely notice a little symbol that pops up if you've spelled everything and done everything correctly here. There should be a little green arrow, and it mentions an override. If you squint, you can probably barely see it on the screen here. It mentions something about an override. Java looks for this method in your class. If it finds it, it will run it even when you call it like this. So I just changed the behavior of printing the object itself. Just the object name. I didn't call any methods here. I just changed that behavior by adding a two-string. If I get rid of it, and I run this code, I'm back to circle at and then a memory location. But if I have the toString, then it'll print whatever I want it to print. So radius in this case. So toString is easy to write, and it can make your life easier. Now, I'm not printing out the actual radius here. I don't have a number printed out. I'm not saying like %f or something like this. There's no way I do this. It's just going to print it out exactly like this %f. So I need a way to print a number in there because that's ultimately what I want. I want a number instead of just some other stuff. Now there are other ways to do this. You could do something like I could do a concatenation and put in radius. This. And it would work for me. And this would sort of give me what I want, but it doesn't let me do this sort of thing. What if I want 2 decimal places? It's giving me 1 right now. There are ways to get 2 decimal places, sort of doing it this way, but there's sort of an easier way to go about it. So I'm going to show you that here in just a second. I have sort of a larger example of a toString. It's sort of related to sort of a playing card type game, but it sort of shows this. It sort of shows this off. So I'm not going to specifically code this one up because we have our circle and our rectangle example. But there is a toString that's down here in the bottom, and in the main version, it shows you that you can print it as a C, or you can actually call toString if you want to. You can do it either way. So I can print out C1, or I can print out C1.toString, and it will give me the same thing. So I don't have to explicitly call the method if I print as a string, which is one of those little niceties that helps us write less code. So if you want to format the string like we do in a printf, so remember it's printf because it's a formatted print. That's where the F comes from. So if we want to control decimal places or potentially do what we would normally do in a printf statement, then we can write it like this. So I say I create a string. So in this case, string s. And I say that equals string.format. And I do what I normally would do in a printf. So if you want to have sort of a standard template for a toString, it would be something like this. Create a string. So S is fine. Do string.format. And then do whatever you need to do in whatever you would do inside of a regular printf. So you have the .2f and a new line, and we want to print radius. And then you can return S. Now you can write this all in one line, but if you just want to get used to using string.format, writing it out like this first and then returning S will sort of get you used to what string.format has to do. It has to save to a string, and then you can mess around with it after that. So if we run this now, here we get the radius with 2 decimal points, and we have the new line in there as well. The reason why there's sort of a double new line is because I already had a new line right here. So technically I'm getting the string, which is radius 10, a new line, and then a second new line. So that's something that you got to play around with and see what you want for what this toString prints out. So that is how you can modify what it means to print an object. So you can do this, and it can be quite useful so that I don't have to type in all of this stuff every time. Because I could literally take this printf right here, just take the stuff on the inside, bring it back over here, put it in my string.format. This time I don't need the C1 dot. I can just use get area and get radius because it will call these methods I have down here. And now I don't have to type this in every time. So back over here with my circle, I can literally just print out. I can literally print out a string, and I think there was a new line already in the output. So I print out a string and I type C1. And then I say make a new string with a new circle with a new value, print out that circle, and I still get that same print. So it can save me a ton of time by just putting the appropriate print that I want inside of a toString. And then to print it, it's just super easy. So that's where toString can be very, very useful. All right, so any questions on toString? Yeah, so I have a quick example here, string.format. So I show a few of the things for doing this for a rectangle, for example. So basically this was string.format that we were messing with. I have a little exercise here messing around with the rectangle. So I do recommend going in there and just writing a quick toString for it. There's an example here of doing that so that you can print out like the height and the width, for example, like we did with the circle. All right, objects can be used as method parameters. You've seen this before with scanner. A class just represents a type. It's kind of like an int or a double. It's just more complicated. It has other variables and methods and stuff associated with it. So you can pass around objects just like you do other variables. And we've done this with scanner before. But unlike your regular variables like ints and doubles and stuff, objects are passed by reference. All objects are passed by reference. There's only one of them in memory when you create it. When you send it to a method, it does not make a copy like it does with ints and doubles and chars and booleans. So any changes you make to an object within a method are just modifying that single version of the object. So just like arrays, we saw this with arrays. Arrays, you send it into a method and change it. Everybody else, all the other methods and all the other sort of things you're doing in your program see that modified value because there's only one array in memory. Objects are the same way. Technically in Java, arrays are also objects. So it's just primitives, int, double, all those that copies are made, and objects where copies are not made. So this is a little sort of simple sort of example here showing that in main, we create a scanner and some object here, a temperature object, and call a method called getTemperature, and you just send them in. You just send their name. Because the getTemperature method takes a scanner and a temperature object. So you treat them the same way that you would any other type of parameter when you're using a method. You treat them in exactly the same way. Just make sure the types match up. Keyboard input is a scanner, so I can send that into a method that takes a scanner. The name, of course, is just that sort of dummy variable name that I mentioned before. It's just sort of a renaming of the object, and you use that renamed version only in the method. So passing them around is something that we will do quite often as well as we do more sort of OOP stuff, and as you learn more about it next semester as well. So you essentially treat them the same as any other type of parameter. There's a special keyword in most languages have something like this that you use to represent the current object within a class. It's the this keyword. The keyword can be a little bit sort of confusing to talk about because it's the this keyword. But in your code, it can help you clarify what you're accessing when you're using a variable name. It's never required. It's not something you have to use when you're coding with OOP stuff. If you came from Python, this is equivalent to self. So Python, they call it self. C-like languages is typically this. Other languages, I think, typically try to stick with either this or self. For like Fortran OOP stuff, you could actually call it whatever you want. You actually have a choice. You could call it different things in different methods. They give you a little more freedom there. But typically it's this or self if you've come from another like Python type language. If what I'm going to show you makes sense, then feel free to use it. Otherwise, you certainly don't have to until you maybe get a little bit more used to it. I like to use it in certain situations. So I think the best situation to show you is in the constructor. So I have a name here called new radius. So you take in a variable. The dummy name for it in this constructor is called new radius. But what if I just wanted to call this radius? What if I just wanted to do this? So I'm taking in a variable. That variable is called radius. I have a radius variable already in class scope. So now I get a warning here, and the warning says the assignment to variable radius has no effect. And notice the highlighting. My normal radius in my class variable, the private one, is the cyan color, but this radius now is all sort of the darker blue. So it's saying this darker blue one is just going to be equaling itself. So that's what the syntax highlighting is showing me here. Well, what if I want to refer to this one? That's where the name of the keyword comes from. What if I want to refer to this radius? That's where you use the keyword. So I say this dot. And now look at the syntax highlighting. It's changed. Now this dot radius is equal to the radius that came in to the constructor. So it can help avoid some of the ambiguity that might happen in this situation. This is probably the most common situation that you end up sort of encountering with this, but you can be as explicit as you want. So in get area, I can say, rather than just radius times math.pi, I can be more explicit and say this dot radius times this dot radius. And I'm guaranteed to someone who's reading this code for them to know that, okay, with this bit of code, he's talking about the radius that's up here. This object's radius. So if you were to read this out loud, that's what I would say. I would say this object's radius times this object's radius times math.pi. Sometimes I will use this just sort of automatically. I'll just sort of start typing and then I'll just say this dot radius. If this makes sense to you, then feel free to do this. You can do it on variables. You can also do it on methods. So we have get radius and get area here in our toString. I can say this dot get radius and this dot get area. Because I'm talking about this object's get area method and this object's get radius method. So anywhere where you have a method that belongs to a class, you can say this dot and call that method. If you have a variable that belongs to the class, so something that is a class variable, so something up here before your constructors, you can use this dot to refer specifically to that variable, even if you have something that is the same name coming into a method. This example of using this is not required. We had a perfectly fine functioning code without using this at all. The way we got around the issue in the constructor is to have a different named variable here than our class variable. So there are ways around using this in this context. Later on, we will see a different use for this, a different context to use the this keyword. And in that case, it would be required. So you will probably end up using the this keyword in the future, but not necessarily in this context because it's not a required thing to do. But I did want to at least mention this. I'll only have a single slide on it, but I did want to mention this because you might see it in other codes. So when you see this, just know that it's talking about this class or this specific object. So it can give you a little bit of extra sort of clarity on exactly what the programmer's trying to do. I don't use them all the time. Again, sometimes I do. Sometimes I'm inconsistent. Sometimes I use it for half of a class and then I just don't use it for the rest. It depends on the sort of mode that I'm in programming. If I'm sort of typing up code and thinking about it and sort of speaking the code myself, I'd say, all right, return this.radius times this.radius, and that I'd sort of speak it out as I'm coding it, and then I might use this, but sometimes I don't. So I can be a little inconsistent with it as well. There's another concept that we've seen a keyword with already, and it's this concept of static versus instance. All the data fields that we've created in our classes so far, so in the circle and the rectangle, they're instance variables because they depend on the object that we've created. If I create object C1, it can have a different radius than object C2. So it depends on the actual object that we're referring to. The example here on the slide is every account object, say in a banking program, every account object has its own name, the person on the account, and has its own separate balance. So as you might guess, in programming, there is an opposite to this. That's static. Every object shares the same variable. So there's only one place in memory that all of the objects of that class look to grab that number. So if one object changes the static data field, all the objects are going to be affected. So I have an example of this with this sort of username sort of thing. So I have a user class. Notice all my variables here are private. We have a string called the username. We have an ID, and I have a static int called number of users that starts at 0. So that's the data associated with my user class. Notice that I also have a toString, and I have my constructor. So the class isn't that complicated. It just has a way for me to print the class, and it just has a constructor that sets some of these variables. In main, I create 4 users. So I create Fry, Bender, Leela, and Zoidberg. Every time I call the constructor, it's going to set the username, which is an instance username. Everybody has a different username. Everybody has a different ID. But look where it grabs it from. It grabs it from here. So when Fry gets created, he gets a username Fry. His ID is equal to the number of users. Only one of these variables exists in memory. So it goes there and it grabs the 0. So Fry's ID, in this case, Fry's ID is 0 when I end up printing him out. But then I increase the number of users variable. So the second time, this value is 1. Since there's only one number of users variable, because it's static, when Bender gets created, he'll get his username, and his ID will be 1. And then he increases the number of users now to 2. So then when Leela gets created, she will get an ID of 2, and she will increase the 2 to 3. And then Zoidberg will get that value of 3. So when you print out the IDs, you're going to see 0 for Fry, 1 for Bender, 2 for Leela, and 3 for Zoidberg. So a static variable is just one that exists, and it's the same for every single object. And when one object, like Fry or Bender or Leela, when they change that variable, all the other objects see the new value because there's only one of them. If I were to sort of draw this out as sort of objects, I would have Fry with an ID of 0. I would have Bender with an ID of 1, and so on. And they would all be accessing the same variable here. Let me draw that. They would all be accessing the same variable number of users, being whatever the value happens to be. They would all access the same one. They don't have their own version inside of their own object. So that's how you can sort of diagram this out. Think of it as being totally separate from the objects themselves. All right, questions on that? Methods can also be static. We've seen that for, at the very minimum, main. If I go to my code for where I'm sort of printing all this stuff out for circles and rectangles, I have a static method. So at the very least, main is static. The meaning is similar. The static method is shared by all instances of the class. But that doesn't quite make as much sense as a variable. At a variable, you can sort of, like I showed, you can sort of diagram it out and say, okay, this variable is sort of separate from everybody, and everybody can access it. You can sort of think about it in terms of memory. A static method is a little bit more difficult to do that. The biggest thing to remember with a static method is that it can't modify instance variables. Because which instance variable does it modify? If the method is shared across all objects, which object does it use to modify an instance variable? So static methods can only modify static variables. There's a static variable, there's only one. So we can modify that with a static method. The power of the static method is that you invoke it with the class name itself. You've used static methods before. You've done this exact thing. This exact thing that I mentioned here. Static method can be called from other methods with the class name. You've done that. POW is a static method. Math is the class name. So you use the class name, not a particular instance. Notice how we never have to say math m equals new math. We never have to do that in our code to call the power function, or to call squirt, or to call abs, or to call cosine or tangent. We never have to do this because we just use the class name and the static method called POW. That's where the real power comes from. If you have a static method, you can call it with the class name, not an individual instance of the object. I don't need to create a new math object and then say m.pow. I don't have to do that. It's just math.pow. So the example in the code here is almost the same as the one we just saw, but it now has a static method called getNumberOfUsers, and all it does is returns the number of users. So the key here, sort of what I just showed with math, is that in order to call that method, I only need the class name, not one of the actual users themselves, to be able to call that method. You can call it with a user itself. So I could say pjf dot get number of users, but that's not the preferred way to do it. When you call a static method, you should use the class name itself rather than an instance of the class. You will see more of this in the future. This is stuff that is not going to go away. This idea of static methods, static variables, these ideas of using the this keyword and private versus public, and then in the future versus protected. This stuff is not going to go away. This is just your first sort of exposure to it if you haven't seen this sort of thing before. If you've come from another language like Python, for instance, Python does have object-oriented programming sort of capabilities, but it's not quite as explicit as this. There are ways to do a lot of these things, but they're not always as sort of either straightforward to do or as necessary to do. So these are things that you will have to get a hold of as we go along this semester and as you continue on in CS, if that's where you're headed. So overall, for sort of this wrap up of this week, a class is just a data type. It's just more complex. So it has some variables, it has some methods. So it's all sort of set up to be a more complex data type. There's lots of predefined classes. We've been using them all semester. String is a predefined class. Scanner, pretty much all the other stuff you've used that needs a dot to do something with it. So like I just saw with math. Math.pow. Math is a class. It has a static method. You define your own classes. This is what you'll be doing all the time in the future. They can represent whatever you want to represent in your program. So I usually stick with this sort of game or sort of physical interpretation because I think that's sort of easier to understand at the beginning. So if you need to have a car in a video game you're writing, then you're going to have a class called car. And that will have variables like, I don't know how fast it's supposed to go, how many wheels it has, what kind of weapons you have on the car, anything you can think of sort of physically related to the car that you need to know about for your game. So this is just the beginning of object-oriented development. We really only talked about two of the pillars, encapsulation and abstraction. In the future, specifically CS2, we sort of talk about those again, and then we go into inheritance and polymorphism. And what all those concepts mean and what they do for us in Java specifically. So that toString thing that we see that Java sort of looks for toString that I sort of hand waved away as to how it looks for it, that's related to inheritance and polymorphism. So that's something that you'll see a lot more in the sort of upcoming semester in CS2. So we'll continue on with more stuff next week where we will sort of still do some sort of OOP type stuff, but there are other topics we need to talk about, things like how do you read and write from a file and how do you do exceptions. And so there's still lots of sort of stuff that's not as related to OOP to talk about this semester, but OOP is something that we will be getting into quite a bit as we continue on. So I'll give you a break from the regular weekly homework. So no new homework this week, so you don't have anything new to grab today. The current homework that is out is due today, so make sure that you work on that. You can go to the tutoring session as well this afternoon/evening. There will be a lab tomorrow, so make sure that you are here for that. We will be doing just a normal lab thing that we've been doing. So that is all that I have for you today. So I will see you guys tomorrow.
Thank you, Professor.
Yeah.
Thank you.